Sorry guys, I'm speaking my heart. Sorry guys. Hey, sorry guys. Yeah, I was speaking. Well, the video of this part is absolutely ruined, so I will make a very fast sum up of what I was saying. Okay, so it's captured on the video. So I was saying my intent is to, let me just really fast do this. Damn, almost 15 minutes without sound. Yeah. Well, so I was saying my intent is to implement the login, the persistent storage of the authentication token on the login demo. Okay, this is going to be be done through a user repo, which I have characterized through an abstraction. That abstraction contains a set of suspend functions which enable us to clear data, update it, and get it. Okay, why suspend functions? Again, because these operations involve I/O, and therefore we need to do it through suspend functions. How are we going to go about it? Using data store, which is, for all intents and purposes, a local storage using the file system, and in fact it's a key value pair. Okay, storage. These are the keys I'm using. This is how I go about getting the values associated to these keys. One thing to note is that store.data, this new API, this is a recent API. If you guys go and look to the Android documentation, you will notice that there's another API which is named shared preferences, which is deprecated, meaning that it's to be thrown away. And the new API is this one, and this uses a reactive approach, as I was saying. So this means that store data is a flow of preferences. Preferences is the data type that captures this idea of key value pair storage. Once I access this flow, I can get the last element, or the first one. It's not relevant in this case because there's only one at each given point in time. So this means that I can get the last element of the emitted by the flow and go and use it. Once I use it, in here is a key value pair store. I use the key which captures type, the type of data expected on the value, and then if it's not null, then I'm assuming that if this one is present, then this will also be present. Okay, I will enforce it in my implementation. Yeah. Okay. So this is in quite very in a couple of minutes, mostly what I've said thus far. Okay. Well, maybe not everything, but at least the most important parts are these. Again, so how about saving? And this is not elegant yet. I will change it. I will comb it. Okay, give it a trim so it looks better. Namely, I can, for example, why not? I can do an extension function of preferences, which to auth info, for example, right? And I can do this like this. And now this yeah, it's better looking, I think. And now I can do this. Preferences to auth info. When I was saying that we could make it look a little better, I was referring to this kind of stuff. Okay, so but yeah, that's it. Again, when I need to clear the authentication info information, I have to do like this. Whenever I wish to edit, to change the contents of the data store, I should use preferences. I should use store data, edit. You see here? And this receives the lambda, which performs the actual transformation. The general idea is this. What is inside here is performed with atomicity, okay? It's ensured by the implementation that this is done everything or nothing at all. So this deals with that problem for us. So therefore, I'm going to state, look, edit this and use this. This is what I intend to do. So what I intend to do is to remove both keys, right? I think there's a simple approach to it, which is, look, clear it. Meaning, instead of removing individually each key, clear everything from this store, which only has those two values, right? And this is it. This is how we go about clearing the authentication info, okay? Again, this is a suspend function, yeah, and therefore this one must be also a suspend function, but that we already know. This is I/O, therefore our API must be comprised of suspend functions. And finally, how are we going to do to save the information? Well, GPT already knows it, right? The Copilot knows it. It's as simple as this. I'm going to edit and pass in the lambda the two operations of setting the value associated to those keys. This is correct. Okay? Okay, guys? This is as simple as this. So meaning that, what I mean is, okay, cool. Oh, by the way, this could be done a little more elegantly. For example, I could convert like this to no, this is not it. I don't want that. I want this. I want auth info to preferences. Something like this, yeah, to preferences map and return it and then store it, okay? But yeah, I'm going to keep it simple for now. Maybe later on I will comb it again, trim it, okay? But this is the general idea. Moving on then. Let me see whether, okay, cool. So moving on, remember our goal, our intent was to, first and foremost, we do the login, then we store the information. How are we going to do it? Well, let's start by doing this inside the view model, okay, like this. The view model, it's here, should receive, obviously, the required dependencies, right? This means that it requires private val user repo, which is not any, is the user auth info repo, right? Auth repo. Cool? Because we receive it, obviously we need to change this get factory and repo. Remember? If you guys don't remember any of this, please ask me, okay? Meaning that this is the function that is called from the outside to get the instance of the login view model, and therefore we need to pass in the dependencies, and again, here they are. Right? Cool? Yeah, that's cool. So now this is the login function, the function which is called from the UI to trigger the state change involving of obviously the login action. Here it is. But in this case, val auth token, we need to save the information, right? Okay, like so. save auth info, and now I need an auth info. And here it is. Okay? I could do this, 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 and finally, once everything is okay, oh, by the way, I need this to return to set login success, right? We should use the token. So let me. Again here, so you are saying instead of storing it here, I could get it again. Yeah, I could, but I already have it. So I usually prefer, instead of asking to the repo for it, because I already have it, I prefer to use the information I have on hand, okay? Because I gave it to the repo in the previous instruction, okay? This is why I prefer to store it here. But yeah, I could. So I was saying here, I'm going to do this. This is the auth token, and this is not the auth token, and this is the auth token. Okay? So, as you could see, now instead of one action, I already have two. First, I fetch from, I do the login with the service, then I get the result and I store it in the repo, okay? And finally, I transition state, which triggers the navigation. I navigate away from this screen. So my point here is, what have I done? Okay, I touched something. You see, what I want to show you guys now is this. What if this becomes complicated enough? You see, what I'm doing here is making the view model more complicated. Why is that? Because now, instead of interacting with only one service, now I have a use case, a flow, okay? I have, first you do login, then you store the token. But this could be more elaborate, okay? This is why we can pull this out, refactor this into a use case, okay? What is a use case? But for now, you guys understood this? It's simple enough, I think, right? So what we need to keep in mind is what we already knew before. This must be done inside the view model, inside of a coroutine. That coroutine is subject to the view model scope. Why is that? Because if the view model terminates, we need the coroutines to terminate also, and therefore we use the view model scope. And these operations must be suspended because they involve I/O. Cool. But now, what I'm going to do is to get this out of the view model. Why is that? Because we can imagine, what if this would be complicated enough, okay, to justify it. So let me show you how. There are several ways to go about it. One is to simply have a use case which implements it, right? Instead of having that there, we can do this here, okay? This is it. Okay, so we can do the login, save it, and return the auth info. The auth info, I'm not actually interested in all the auth info here, but it's okay. Here I will call the information, the function, which is called perform login. Nice. Perform login. And perform login receives the credentials, the login service, and the repo. Okay, cool. Val token equals to this, and here we pass in the token. And this is, it's nice, right? This is one way to go about it. Why should I do, why am I doing this? Well, because now I can independently test the flow, the use case. This is a function which I can test independently, right? By its own, which is a nice thing to have, right? And the view model stays exactly the same, but I can test it independently, okay? I can test the use case independently. And this is one thing, one way to go about it. I confess I'm not very, I don't have a strong opinion on whether this is the best approach or the one I'm going to show you guys now, okay? But I'm going to show you guys another one. Instead of the view model receiving these artifacts, he could receive the use cases he's going to use, right? Why not? Well, the view model is about triggering use cases, right? In request of the UI. So why shouldn't I receive the login use case, right? Why not? And that's it. You're getting the idea here? I pass on the function, which is the use case. That function can do whatever it pleases. Again, I'm increasing the simplicity of the automated tests I will be using. Here, for example, instead of performing login, I will login use case like so. Okay? But the problem, login use case receives, what is the login use case? Let's see what it is. It receives all of this, right? So now I have the use case and also the service and the auth repo. And again, I'm going to give it, and of course, I'm going to give it the credentials. The use case will have the service and the auth repo. Do you have any objections on this? Well, I have. Do you have any objections? Any criticism? You see what I'm doing? I'm saying, look, instead of presuming that this is the implementation of the use case, why not passing it in too, so I can easily test? But because that is always our goal, how to simplify our automated tests. And I'm saying, okay, cool, let's say for the login use case, we need suspend functions which receive these 3 parameters. And one possible implementation is this one, the real one. But we could hand it over to the view model fake implementations, right? This simplifies tests. And now, instead of passing in only login use, these 2, I also pass in the login use case. Any objections? You good? Yeah? Well, I have one objection. I had 2 dependencies. Now I have 3. Right? There were 2. Now there are 3. Okay. Can we do better? Yeah, we can. I'll leave it up to you guys. Okay? I would prefer simply to pass on this dependency, the use case, right? Which I can give to the view model, the actual implementation or a fake one for testing purposes. So instead of having all of these dependencies, I would like to have only this. But I will not show you guys how. I will expect you guys to do it if you can, okay? I don't want to bother you with this detail, okay? So for now, it will stay like as so. This is not the auth repo. This is the This is it. And now, again, I need to pass in this. Oh, by the way, in the get factory, we can assume that this will be the actual implementation, the perform login. Let me see if, again, you have any objections. Login, perform login. Login use case, perform login. Yeah. And now we have objections. Your Honor, come this. How they say? No? You're good? Okay. So am I then. The service is the service equals service. And here it is the auth repo. So what I'm showing you guys is the repo. How to go about implementing more elaborate use cases on the view model while maintaining the ability to test it. Okay? This is the goal. It's not perfect, in my opinion. I don't like this. It's too much, too many dependencies. I would prefer to sum it up to a single dependency. Okay? But I will leave it to you guys. So let me just design challenge. How should we do to make sure a single dependency is passed to the view model? That is, okay? That is the challenge. You already knew, you know, that was my intent here. Oh, and by the way, again, design challenge. Should we also pass here the use case function? Why? Why? Why not? I like it. I like it. Okay, guys, so I will leave this up to you so you can think a bit on this. Sorry. Okay? I will not go and solve it for you, but I will leave it as it is. You understood what I'm aiming at here? So, simple. Instead of having a single interaction, the view model now has two interactions with a couple of pieces. Okay? And it's simple enough. This you may ask, look, it's why complicate this? It's not complicated. I call the service and then I call the repo. Yeah, but it can be more elaborate. And we want to preserve the ability to test this. Look, no. Okay? I don't even know who it is. Ah, I know who it is. He wants to deliver me the Astrobot. Let me just for sure. Yeah. Astrobot. I've ordered it. Let me just check. Sorry. I bought Astrobot, yeah, on sale. Olá, viva, desculpa, epá, agora é que eu percebi que podia ser a entrega do jogo. Pá, estou em aula, pá. Diga-me uma coisa, como é que a gente faz isso? Você consegue pôr isso aí, ponha, no primeiro B ou A, tanto faz. Pode ser, sim, são os três apartamentos meus. Muito, epá, desculpa lá, estava numa aula, obrigadíssimo. Tchau, obrigado. Okay, it's Astrobot. It makes sense. I bought it for 30-ish. Okay. I bought Spider-Man 2 on Black Friday. Bought Spider-Man 2 and physical copies and Astrobot game GOTY of last year. So I intend to play it. Okay, cool. Back to Earth. Yeah, here it is. So this is mostly what I intended to show you guys today. Okay. Again, I will leave this as a blueprint for you to go and look at it and make sure that you observe this. Remember, we can always do however we can, but with not a care in mind. But this helps us in dealing with the increased complexity of our solutions. Okay, this is important, I think, software design. But again, I will leave it up to you. Finally, I just want to show you before I end this. I want to show you one. Reactive approaches are pervasive. They are everywhere. As you have seen, a simple stuff as simple as a key value pair store has a reactive API. Here, remember this. You see? Here it is. Okay? In this case, I'm using a pool API. But what if I wanted to have a reactive API? And you may ask, why would I? Why would I be interested in having a reactive API? Just imagine that, what if we get logged out? We need to detect logging out to make sure that we navigate away from wherever we are, again, to the login screen or the title screen, depending of your solution. So it may be important to immediately be aware of the change of the logged in status, right? So this, instead of providing that information through the pool model, we could actually do it through the push model, like so. Let me just close stuff up. Login service, it's done. You're also done. You are also done. And you are not done because I want to have here a reactive interface. And how is it a reactive interface? Well, no, not is logged in, sorry, but instead the auth info, which is of type flow of auth info nullable. If by any chance the flow has a null value, we know we are not logged in. If the value is different from null, then we are logged in. This is the flow that emits the current authentication information, or none if none is stored. Okay? And how do we implement this? I will leave it for now as an exercise. I will get to this later on if you guys... No, nothing like this. Now I want to do here val override auth, like so. Yeah, not yet implemented. Okay, just to give you the chance to think of it for a while, okay, before I show you the solution. It's easy enough, but yeah, I'm going to give you the chance to think of it for a while. Okay, so I will do it like so for now. Next Monday, I will show you how this is done, okay? But it's simple enough. Finally, and I want to, then I will end, okay, today's lecture. I want to show you guys something which I've done. So, at the end of last, I'm aware that there's a huge diversity of background in the assistance. I'm aware of it, okay? And for some of you guys, this is simple enough, but for some of you, some other, this is not simple, because although it's not complicated, it's too much, too many things. A new language, a new concurrency model, everything is new, and therefore it becomes quite daunting. I understand it, okay? So But some of you guys, at the end of last week's class, asked me, look, do I really need to use flows in my solution? I'm using option A. So do I really need to understand what's going on here? Well, regardless of using or not I/O, we can actually use the reactive model. Okay, so I'm going to show you. I will publish this code in the repo, but it's not intended as a demo. It was something I have done myself for the PhD. I'm studying artificial intelligence for games, and I have done this, which I'm going to show you guys, and I will give you the code in the repo. Okay, so you can look and see, no, there's no I/O involved here, and regardless, I actually have a flow. Okay, so the reactive approach to this, to the design of applications, it's not a result of using I/O only. Okay, it's a new, or it's not new, because this is not new. Flows are new, the reactive architectures are not. I was saying, so this, I was saying, Maze Pathfinder, yeah. So you guys don't think that this is due only to the existence of, no, of I/O, okay? So I'm going to show you first and foremost, let's run this. This is something I've done to have fun too. Well, yeah, the ways we have fun are. Can you see it here on the right? So this is a maze, and my intent here was to illustrate the behavior of different pathfinding algorithms. Okay, so I could see it happening. Okay, the search. The general idea is this: at each step of the algorithm, I look around and to the adjacent states, and I evaluate which of them is the best one to proceed and evaluate. Let's see breadth first approach, find path. This is evaluating all the siblings. Look, at any given level, it expands. You see here, it expands the adjacent, all adjacent, breadth first, okay? And finally, it finds the path. It's an approach that instead of drilling down through the search space, it evaluates breadth first. If you imagine this as a graph or a tree, it's searching in horizontally, okay? All adjacent. There's another, finish, reset. Other, these are the algorithms I've implemented. I will show you guys the A star. I have here a depth first search. This goes like this. Shows this is going straight at it by chance. This is being lucky. Okay, it selects the first node, the first adjacent node, that because we are getting lucky, it finds the perfect path. Okay, this is because we got lucky. By the way, how do I know it? Because, well, I understand the algorithm, but I also have this depth first search randomized, which instead of getting the first node, randomizes. Let's see. Ah, you saw, it just went away from it. So it's not guided at all. It just got lucky the first time, right? And now we almost got lucky, but we can get more, okay? So this is the general idea. Why I'm showing you this? This is, well, I find it fun, at least for me it's fun. I have also the A star, the notorious A star with two distances, find path, and let's see the A star algorithm, which is guided, okay? So it has a heuristic which helps us decide where to go, okay? And he found it, at least, okay? So these are, if you are curious on how I have implemented those algorithms, you can see it here. They are here. And, oh, sorry. Domain, Pathfinder internals, Pathfinder. I support these, and then I have a general form. These algorithms obey a general form, okay, which is this one, Pathfinder internal, with a open set, closed set. Well, I will not get into the details, but they are explained here. So if you want to look at it, it's here, you can look at it. But my point is this. You see here, the Pathfinder returns a flow of states, which is what is the current state of the open set and the closed set and the path found thus far. This is why you are looking at it step by step. You see? Searching. Next step, next step, next step. Instead of computing them all at once and getting out with the solution, I am at each step checking the next available states and producing information of it to be displayed. Okay, so, and there's no I/O here. Okay, this is simply computation. And regardless of it, we are using a flow because it's helpful to use a flow, to use this reactive approach to the design of our solution. Okay, so I will give you guys this, show you how I went about it, and eventually so you can grasp, have a more broad understanding of this. But I will continue to provide examples and more examples and yet more examples of this approach so you can understand it. I wish, Kesh. We are talking about software design in Android. Okay, so cool, guys. Finally, just as a amuse-bouche, I have here a small DSL which allows me to define mazes in a very simple way, like so. Let me just see where I'm using it. Find usages. Here it is. The maze function. Not you. Find usages. Here it is. Yeah. Okay. Here it is. So I've built a small DSL. So my maze is always the same, but I can change it easily by providing a different configuration. This is DSL. I think you are going to study this in LIA. I think. I'm not sure. You didn't? You never saw a DSL made in Kotlin? You use them all the time, okay? So use them when you are using this, and you use them when you are using, for example, Compose. We are using a DSL, and they are designed more or less like so, okay? Mega vid. Okay, guys, and this is it. So this is what I have for today. I wanted to show you guys how to store information persistently, locally, using data store, which is a key value pair storage. So it's adequate for very simple data. Elaborate data is to be stored somewhere differently. For example, using MySQL database, accessible through Room API. I will show you guys later. This is local storage, okay? Storing locally the information. Again, because this involves I/O, I always start by, I will give you guys this, okay? I will share this and put in the repo. I was saying here, I always start by designing the abstraction, okay? Here it is. And then I proceed to go to the implementation. The abstraction simplifies testing and allows me to inject fake behavior. Fake behavior is very interesting in development time. So because I can control with detail what happens and therefore see how the consumer code reacts to whatever I throw at him. Okay, this is important too. And finally, we have here the implementation of it. Simple enough. Of course, the API has more stuff, but I think this is enough to understand its use and to go about using it in our use cases. In this case, for you guys, I think most of you will store this information there, the authentication token, so it's more or less direct, applying directly this, okay? This is why I'm not doing everything just yet, so to give you guys room, space to maneuver, okay? And that's it. If you don't have any questions, we will continue. Now I think option C has everything it needs to implement up to the end. So there's nothing left for you guys that are implementing option C. Option A, there's a long time, you already know everything you need to implement option A. Regarding option B, there's something lacking still, which is Firestore. Okay, Firestore is a document database, meaning that its contents are stored as JSON, usually as JSON objects, and organized in collections. We can, and it abides by the push, this reactive approach. So it provides a reactive API. I will show you guys sometime in the near future this. I'm trying to figure out whether next Monday I will look into automated tests here, or whether I show you. Yeah, maybe okay. My intent is to build from end to beginning something. In the remaining of the semester, I will use Mondays to build a solution from start to finish. I'm thinking of tic-tac-toe because it's simple enough, and I think I have the time to implement it straight through, right to the end, okay? But instead of starting by the UI, I'm going to start by the communication infrastructure, meaning using Firestore to communicate the new state of the game, okay? So to accelerate the access to the presentation of Firestore, so option B can be done, okay, to its completion. Okay, guys? So I'll see you guys in the next class, and next Monday we will start tic-tac-toe, okay? Bye-bye. I will see how much content of the video is ruined by being silent, and I will cut it out, okay? So it's, well, sorry about that. Okay. Firestore is exactly as yeah, it's a key value store. It's exactly the same as MongoDB, with an important exception. At least when I looked at MongoDB, it had no push communication model, so I had to ask periodically. In Firestore, we can receive notifications whenever a data set changes. No, its implementation will, yeah. Guys, yeah. So let me just shut it down. Bye bye, guys. Que chatice ter ficado estragado o vídeo no